Okay, so welcome back. Now what we're going to do is we're going to talk about limits at infinity that are infinite limits. Okay, so infinite limits at infinity. Okay, so in other words, we're going to look at, hey, what happens if the graph just goes off to infinity as x gets arbitrarily large or sufficiently large, or if x gets sufficiently negative large. Okay, so again, we've seen these in algebra, these situations, but now we're going to informally define what we mean in terms of limits. Okay, so definition 3, again, this is an informal definition. So it says, we say a function f has an infinite limit at infinity, and we write the limit this way. So the limit as x approaches infinity of f of x equals infinity. If f of x becomes arbitrarily large, again, informal, so as f of x becomes arbitrarily large for x sufficiently large, okay, so that's one part. We also say a function has a negative infinite limit at infinity, and we write the limit as x approaches infinity of f of x equals negative infinity. Okay, if f of x being negative, so again we're going negative, and the absolute value of f of x becomes arbitrarily large. So again, just like before, this is just saying, hey, as f of x becomes arbitrarily large in the negative direction, okay, for x sufficiently large, okay. Now we can also define infinite limits as x approaches negative infinity similarly, okay. So this is the informal definition of what we mean by having infinite limits at infinity, okay? And again, things like this, when you have a graph, let's say something like this, and you have a graph that does, well, something like this, right? So as x goes to positive infinity, this is going off to infinity, right? It's not approaching any specific number. Or if x goes to negative infinity, it's still going off to negative infinity in this case, okay? So in both of these cases, you would have infinite limits at infinity. Okay? Have a good day.